All right, let's take a look at an application question. So Allison has let her hamster run loose in her living room. The position function of the hamster is s of t is equal to 5t over t squared plus 4, where t is greater or equal to 0, where s is in meters and t is in seconds. How fast is the hamster moving after 1 second, and when does the hamster change direction? Okay, so we know that when we're looking at the speed of the hamster, we're technically looking at velocity. We understand that the velocity function, v of t, which is the velocity after t seconds, and velocity is recorded in meters per second, this is the first derivative of our position function. So technically you can write this as ds over dt, right? Using Leibniz's notation. So let's find the derivative of our velocity function because we want to figure out how fast the hamster is moving after 1 second. So if we're finding the derivative of our position function, okay, if we're finding the derivative of our position function, I'm going to utilize the quotient rule. So you do d of dt of the numerator, right, 5t, times the denominator, t squared plus 4, minus the derivative of the denominator, t squared plus 4, times the numerator, which is 5t. And then we're going to divide this by t squared plus 4 squared. Okay, so we square the denominator afterwards. Now I'm just going to do the derivative and clean this up. So basically you get 5 times t squared plus 4 minus the derivative of t squared plus 4 is 2t times 5t. And then this is over t squared plus 4 squared. Okay, let me just clean that up a little bit. All right, so this is t squared plus 4. And so this is your first derivative. You can kind of simplify the numerator out. This becomes 5t squared plus 20 minus 10t squared, right? And you can kind of make this into negative 5t squared if you want, right? So this is just the numerator here, right? So let's just kind of draw an arrow here. This is just the numerator, so I'm just going to clean up the numerator. So this is negative 5t squared plus 20, right? So if you look at your velocity function, v of t, right? So this is your numerator. You basically get negative 5t squared plus 20, and this is over t squared plus 4 squared. Okay, so that's your first derivative. We want to figure out how fast is the hamster moving after 1 second. Well, we're basically doing v of 1, which is negative 5, 1 squared plus 20 over 1 squared plus 4 squared, which basically looks like 15 over 5 squared, which is 25. Okay, so the velocity tends to be 15 over 25 meters per second. If you want to simplify this, if you divide this by 5, you get 3 over 5 meters per second. So it's approximately 0.6 meters per second. Okay, so this is how fast it's moving after 1 second. Okay, now when does the hamster change direction? Now this is a very important concept to understand, right? When does a velocity vector become 0? Okay, so you basically want to figure out when is the velocity function greater than 0, and in the other intervals the velocity function will be less than 0, right? When the velocity function has a different sign, that means that the object is moving in a different direction, right? So if you have a positive velocity and you're going east, if you have a negative velocity, like say this guy here is east, right? If you have a negative velocity, then it would be moving west, right? So, and vice versa. So if you have a velocity, if you say positive is north, then negative would be south, right? So it's going to be, it's reference to whatever dimension you're looking at. North and south represent the y dimension, and then east and west would represent the x dimension, right? So when does the hamster change direction? Well, we kind of need our velocity function to do this, right? So we can note here that our velocity function, v of t, is equal to negative 5t squared plus 20 over t squared plus 4 squared. All right, so I'm just going to make some space for this. I'm just going to erase this guy out to look at part B. Okay. All right, so if we're basically looking at when is our velocity going to be positive or negative, let's just figure out when is our velocity going to be positive first, and then we can look at the negatives. Now to do this, we basically have negative 5. I'm just going to factor this out. So you get t squared minus 4 over t squared plus 4 squared. Now you can understand that the denominator is always going to be positive, right? But the numerator can be factored out, right? So this is basically our function. This is our first derivative function, our velocity function. And the numerator can be factored out as t plus 2, t minus 2, because basically this portion here looks like a squared minus b squared. Okay? And we have t squared plus 4 squared. Okay? Now, because the denominator is always going to be positive, we don't need to assess this. Our sign change is going to be based on the numerator specifically, right? So what you could do with this is we need to figure out values that would make the velocity 0. So when the velocity is 0, the object would be at rest. We can understand that if you let t plus 2 times t minus 2 equals 0, the object will be at rest when t is equal to -2 or +2 seconds. However, we can understand that time can't be negative. T has to be greater or equal to 0, so t cannot be equal to -2, right? So when we're looking at intervals, we're going to be basically looking at intervals between 0, 2, where the object is at rest, and also positive infinity. Okay, so these intervals are going to be 0 and 2, and 2 and positive infinity. Okay, now the only two factors that we need to be looking at is this t plus 2 and t minus 2, right? So in this case, when we have -5 t plus 2, t minus 2, we don't have to look at the denominator because it's always going to be positive, right? So our denominator will not affect the sign of our velocity function. This is t minus 2, right? Between this interval of 0 and 2, let's say that t is equal to 1 second. So if t is equal to 1 second, I'm just going to change colors here, just kind of demonstrate this, but if t is equal to 1 second, we can notice here that this is positive, this is negative, and there's a negative on the outside. We have two negatives and a positive, so this is going to be positive. Okay, so this means that the velocity function is going to be greater than 0. So if the object is moving east and that's the positive direction, the object will continue to move east. Now, if we're looking at 2 and positive infinity, let's say that t here is equal to 4. Right, so we basically have positive, positive, and negative. And this is going to be negative. So between 2 and positive infinity, we can understand that t is basically going to be can be negative, right? So we can understand that the direction change actually occurs after t is equal to 2 seconds, right? So normally it's a positive velocity, right? So v of t is going to be greater than 0 when t is greater than 0 but less than 2 seconds, right? And then the velocity will switch directions and be less than 0 when t is greater than 2. So the change in direction actually occurs before 2 seconds and after 2 seconds. So that's the idea behind it.